And pen, let's see. Okay, good. Okay, practice test 1, number 1. So we have a titration. That's funny, below, it's to the right. Couple things that the other class had asked about. How do you know what this volume pertains to? So we know from this curve that somewhere we're going to use 25 milliliters, but is that the acid or the base? You can tell this from two things. First off, in the question, they're going to give you a volume for sure. And they will give you 1 molarity. Well, they gave you the volume of the acid, so therefore this is the volume of what? This is the volume of the base. So you can tell two ways. The first way is you read the question and you see which volume was given in the question. The volume at equivalence would be the volume for the other one, the base. If you give you acid, the acid if they give you base. The other way is this ends acidic or basic up here on the titration curve? This is very basic. Wherever the titration curve ends, that is the volume for the equivalence point. So if you end basic, the volume at equivalence is for the base. If we ended acidic, the equivalence volume would be the volume for the acid. Okay, so that was one concept that a lot of students were confused by. Next thing, so how do we do this now? Let's look at what we're given. So I'm going to summarize all the given information. I've got 15 milliliters, and that's my volume of HA. I'm given 0.2 molar, which is the molarity of the HA. I also have 25 milliliters, which is the volume of the base. In this case, they tell us the base is NaOH. And we are trying to find, first thing, concentration of NaOH. Molarity of NaOH equals question mark. When you have a volume and a molarity for the same thing, you can get moles. And we're going to do stoichiometry. Now, there was another question in the other class. For this unit, chapter 17 only, we are going to always assume a 1-to-1 ratio for moles of acid to moles of base for stoichiometry. In chapter 4, it was not always 1-to-1. This chapter, it is 1-to-1. By the way, if anyone has a question, it's okay. I can pause this if you want to ask things. And so if you don't want to be heard in the recording or whatever. Okay, so volume and molarity, I get moles. We need liters. This is the volume right here. Volume, molarity is always moles per liter. And don't forget to write what kind of moles you have here. So the 0.2 moles per liter of HA. So remember when we did chapter 4, we always talked about molarity as moles per liter. You might want to rewrite it as moles per liter. We use it as a conversion factor. Now, we always want to go from moles of the acid to moles base if we're given acid and we're looking for the base. And I'm telling everyone, and some of you might ask me later, and don't laugh at your classmates if they ask, because it's okay if you didn't hear this, but I'll repeat it a couple times. For this chapter, the moles acid and the moles base will be a 1-to-1 ratio. Only for this chapter. All right, so we can find from this moles of our NaOH because everything else cancels out, and we get 0.003 moles NaOH. How do you get molarity from moles and the volume? What's the unit? What are the units for molarity? Moles over liters. So I have moles and I have liters. So I can get the molarity of the NaOH, 0.0030 moles NaOH over 0.025 liters. And can someone tell me what that comes out to? Was it the 0.013?
No, 0.12.
Oh, 0.12. 0.12 molar NaOH. Okay, so that's one of the answers for that problem. Next thing, what is the Ka of the weak acid? Now, this is another place where students get really confused. I talk about the half equivalence volume, and students don't know what that means. Half equivalence is the equivalence volume divided by 2. When I say half equivalence. The half equivalence point. That the half equivalence is V equivalence divided by 2. That's hard to read because I've got other things in there. Let's erase this stuff here, this stuff here. Okay. So the half equivalence point, you go to the equivalence volume divided by 2. The equivalence volume was at 25. We used that for the first part. What is 1/2 of that? 12.5. You go to 12.5. Now, where am I going to go up to? So what? That's half equivalence volume. I want the half equivalence point. When I say a point, what do we go to? The line, the graph. We go up to the graph, and then we read off the y-axis. We read the pH from that point. And it's around 4. I couldn't draw this exactly correctly with this pen, but it brings us to 4. So that tells us that the pKa is equal to the pH at half equivalence. I've told you that before. You should know that. The pKa of an acid being titrated is the pH at half equivalence. So the pKa is 4. I asked you for the Ka. What's the equation for Ka with regard to pKa? Ka is what? Very good. 10 to the negative pKa, which is 10 to the negative 4. And with this, you really can only keep one significant figure from this graph because you don't have data that are dividing this into smaller increments so you can read it better. So you can just leave that as 1 times 10 to the negative 4. That's your Ka. Okay, and then the last part is, what is the pH at the equivalence point? So let's erase some of this. Okay, the equivalence point pH, not the half equivalence point pH. You need to recognize the equivalence point. To find the equivalence point, you see where the curve goes straight up and down, and you have to see sort of a mirror image between where it starts to rise and where it stops rising. Halfway between those is the equivalence point. So you look at this region of the sharp increase, and you go halfway between the top and the bottom of that, and that is the equivalence point. And then you read off the pH. So the pH at equivalence for this particular graph is approximately what? There you go. There's number 1. Okay, number 2, they've shown you the equivalence point on this one. You should notice, so the rise, where it rises, so it's halfway between those 2 points is right here. So that's why that's the equivalence point. So you look for the sharp rise. The middle of the sharp, just the rising part, the middle of that rising part is your equivalence point. Okay, is the titration curve shown to the right? Strong acid, strong base, or weak acid? Weak, is it who's the start, who's the end? You know this just by the pHs. Okay, so, and it says, how do you know? So you look at the pH. So what's the initial pH, everybody? What is it? 1. Okay, I heard 4 somewhere, and I was like, no, it isn't. Okay, so the initial pH is 1. Anything less than 2 is a strong acid. If you start below 2, you're starting with a strong acid. So initial pH is 1, therefore strong acid. And the final pH. What's the final pH?
12.
Yes, actually right at 12. 12. Therefore, okay, anything 12 and above, strong. 2 or less, strong. 12 and above, strong. So from 14 to 12 and from 0 to 2, we're starting with something strong, where we have something strong. So you're just looking at your beginning and your ending pHs, and that tells you.
Talking about the base? Yeah.
It depends. If you end basic, yes, it's talking about the, oh, let me back up. Hang on. I'm going to answer that a little differently, but we'll get back to that. Let's finish this. So final pH is 12. Therefore, strong, we started with an acid, we're ending with a base. Okay. If you're wondering what you start with is that initial stuff. If your initial stuff starts basic, you're starting with a base. Where you end over here, this ending part, tells you what you're adding. So what you're adding is where you end up with the pH. If your pH ends up basic, the stuff in the burette was basic. If your ending is acidic, the stuff in the burette is an acid. Because remember, this curve represents we're adding something to the initial amount. That first point right here is the initial amount, and then we add either base or acid. If your pH is increasing, you're adding base. If your pH is decreasing, you're adding acid. Does that make sense? Okay. All right, so this answers all of number 1. Sorry, the first question of number 2. Okay, if the initial volume of the acid was 15 mils, so I now know V acid is 15 mils. Molarity of the base is 0.10 molar. Molarity of the acid is question mark. All right, so again, students get confused. The equivalence volume, is it for the acid or the base? I can tell just from looking at this information. I go to the curve. I know that the equivalence point is at 50 milliliters. Now over here, you're told milliliters NaOH added, so I know just from that curve that this is milliliters of base. But I could also tell from the ending pH. The ending pH is basic, therefore the equivalence volume at equivalence is for a base. Other way you could tell, right here, which volume is missing? Girls, which volume is missing?
Base.
The base. So V base is 50 milliliters. Now I need to do stoichiometry. So, volume and molarity. Which one do I have both the volume and the molarity for? No. Sorry, it's okay, it's okay. I don't know the molarity of the acid. I have the molarity of the base and the volume of the base. So I can use those two to get moles of base. And then remember, on these problems, we're assuming a 1-to-1 ratio. If there were not a 1-to-1 ratio, I would give you the reaction. Okay, so we're assuming 1-to-1. So I have 0.050 liters times molarity of the base, and we use that as a conversion factor. 0.10 moles NaOH to 1 liter, and then 1 mole NaOH to 1 mole of, we know it's a strong acid, so I'm going to write SA for strong acid, only because we know that since, oops, I can't do that. I have to stick with this. So that equals, this stuff over here, equals 0.005. I wrote something wrong. Hang on. This is 0.10, not, did you catch that? You see that? This is 0.10 over here. Okay, so that's 0.0050 moles of the strong acid. And I have the volume of the strong acid, so what do I do to get molarity? Moles over liters. So up here, another question they had in the other class. When I ask you for concentration, you have to convert that in your head. You have to translate concentration. She's asking me for molarity. Anytime I ask you for concentration, you're looking for molarity. So moles over liters is molarity. Where's the liters of the acid? Right here. 0.015 liters. Is that 0.33? What does that come out to? No, it doesn't.
Yeah.
What was it? 0.33 molar of the strong acid. Okay, so we've, yes, no? 50 divided by 15?
It is.
Okay. So I've answered that question. Oh, and we're done with that question. Okay, number 3, another titration curve. So just another example like what we've been doing. Okay, which curve is for a strong acid, strong base, and which is a strong acid, weak base? How are we going to know? What do we look at? We just look at the pH. So right here, if we're starting at 13, basic or acidic?
Basic.
Basic. Okay, pH is 13. So the black line is for a strong base. And then we'll check where we end. We end at 2. So is that a strong, over here, somebody? Strong acid. Black line, strong base with weak acid. Who is the titrant? I didn't, oh, sorry, right, strong. I just, okay, who, the titrant, the stuff in the burette?
The acid is because it ends at the acid.
Good. The stuff in the burette, the titrant, which is the stuff in the burette. I didn't ask you that, but just I want to make sure people realize that. The titrant is the strong acid.
Oh.
Okay, so now the blue line. Where do we start? Grace, where do we start? Blue line. We start at 11. So are we starting with a weak or a strong? Good, weak base. We're starting with a weak base. And notice the ending is the same here, so we know we're ending with a strong acid. Weak base, strong acid. To write this down on the test and get full credit, you need to write initial pH is 13, therefore strong base. Ending pH is 2, therefore strong acid. And this, the blue line, initial pH is 11, so weak base. Ending pH is 2, therefore strong acid.
When does the equivalence point come into it?
Not till later.
But I mean, like, to determine which is
Okay, how do you know which is which? What is the molarity of the base? Okay, so let's start writing down what we are looking for and what we know. So, molarity of the base is question mark. That says, what is the molarity of the base? We have 25 milliliters of base, so the volume of the base is 25 milliliters. Notice I'm taking the stuff out of the sentence up there and trying to organize it so that it makes more sense to me. That's all they've given me. Now, you might not have noticed this right here. They gave you the molarity of the HCl on the graph itself. So molarity of the acid is 0.10 molar. So we also knew it was a strong acid because we know HCl is a strong acid. You could have written that. The graph tells me it's HCl that we're adding. So I know that's a strong acid. That would be an acceptable reason for how you know you're ending with a strong acid. Okay, and then the equivalence volume right here, 50 milliliters, is now, there's 3 clues that tell you that that's the acid volume. 1, you're told HCl added, so we know it's an acid that's being added. 2, we end acidic, so we know also that that's the volume of the acid. And 3, the only thing I'm missing here is the volume of the acid. So we know that that is 50 milliliters. And now molarity times volume gives you moles. Moles to moles gives you the moles of the other thing, divide by liters to get molarity. I'm not going to go through the rest of that because we've done that twice before. This one. Okay. What is the pKa of the conjugate acid? You have to read carefully. Of the weak base being titrated. So we need to go to half equivalence, just like before. When we're talking about the pKa, or the Ka, or the pKb, or the Kb, we go to the half equivalence point. Equivalence volume is 50. What's my volume at half equivalence point? 25. So I go to 25, I go up to my graph. This is my half equivalence point. I go over here and I see pH is 9 at half equivalence. And the pKa of the conjugate weak acid is the pH. The pKa of the weak base is the pOH. pKa is pH, pKb is pOH. So pKa is 9. If I had asked you for the Kb of the weak base, what would you have to do? You could find Ka. So we know the Ka is 10 to the minus 9. Ka times Kb, this times Kb is 10 to the minus 14. Easier way is to recognize, we have pH plus pOH is 14. pKa plus pKb for a conjugate pair is also 14. So we know the pKb is just 14 minus 9, which is 5. I didn't ask you that question, but that's how you would have done it had I asked it. Okay, so we won't solve for completely, but, oops. The reaction PbBr2 makes Pb2 plus 2Br minus. We know we're dealing with this reaction because you're asked for the KSP for lead bromide. Okay, it's in the presence of lead nitrate. You look for the common ion. You have two things in here. They're not reacting with each other. It's just that one interferes with the other reaction. Lead 2 is in common. I don't care about how soluble this stuff is because nitrates are always soluble. And I asked for the KSP of something else. So whatever I ask you for the KSP of, that's what you're dealing with. Okay, so Y is the solubility. Now, normally we would have a 0 and a 0 here, but this time we don't. This is not 0. It's right here. Lead 2 nitrate. This is 0.10. The rest of the problem is exactly the same. ICE, minus x, x 2x, y minus x, and you know that's going to equal 0 because y is how much can dissolve to get it saturated, which is at equilibrium. So if you're told saturated, that's at equilibrium. 0.1 plus x, 2x. Note, we're going to get a really small, we have a small KSP, so we assume x is much less than 0.10, so this is approximately 0.10. We're going to ignore the x there. So KSP is Pb2 plus times Br minus squared, which is 0.1 times 2x squared. And we were given the value right here, 4.6 times 10 to the negative 6. And you solve for x. And x equals y. And y, whatever answer you get, that's your solubility. Don't forget to put in molar. Did anybody get the right answer here? And you can tell me what it is real quick. 0.00 what? 34 molar. So your solubility goes down when you have a common ion. Number 7. This is a titration problem. Issue here. We've got 2 volumes. Anytime you see 2 volumes, you need to do dilution for every chemical that you're adding. So right away, because you see 2 volumes, you say, oh, I need to do MIVI is MFVF. So we have NaOH. We're going to do MIVI. So Mi 0.1 molar. VI is 20 mils. Is MF. V final. We have to add these together. 20 plus 30, 50 milliliters. So MF is going to be is at 0.04, 0.04 molar. You do this for all the chemicals that you're given, only when you have two volumes. So acetic acid, HC2H3O2, initial molarity 0.2 molar, initial volume 30 mils, equals MF times the final volume, add them together, still 50 mils. It's the same final volume. So MF is 0.6 times 0.12 molar. Okay. Now I need to do an ICF box. These F's on the final molarity have nothing to do with the F in an ICF box. You have to realize we're diluting, that's our initial stuff. It's not the reaction yet. So now we have a reaction. I'm just going to write OH minus plus the weak acid makes A minus plus water. Okay. Because I don't want to write out the whole chemical. This is your acetic acid here, and this is your acetate, the conjugate base. So OH minus, the NaOH is your OH minus 0.04 for your I. The weak acid right here goes in the weak acid, 0.12, 0. We don't care about the water. C, whoever's less is limiting, minus 0.04. Minus 0.04 because 0.04 is less than 0.12. And this will go up by 0.04. Final, 0, 0.08, 0.04. You do an ICF, and then you have to do an ice box. And students always ask, how do you know if you start with an acid or a base? It doesn't matter. Start with the one where you're given the Ka. And I had a mistake in here, and I emailed everybody. This should not say ammonia. It should say acetic acid. Okay. Did anybody not get that email? I thought I had fixed it, but clearly I haven't. Okay. So I need to do an ice box. And I'm going to do a Ka ice box. So I will write what the weak acid is. It's acetic acid, HC2H3O2. You should know from the last chapter. Kas, it's always the acid plus water makes, what do we always make? Hang on, someone else. Olivia, what am I going to make? I've got the acid plus water. What is this going to, this is an acid. What's the water going to become? Excellent. I'm going to make H3O plus and Cheyenne. What else? C2H3O2 minus. Excellent. The F row goes into the I for ICE 0.08, because those were molarities. 0, 0.04 minus X, 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 0.08 minus X, X, 0.04 plus X. Okay, I'll do this over to the side here. So now I know the Ka, which is 1.8 times 10 to the minus 5, equals products over reactants. What do I assume about this right here? I assume X is really tiny. So anytime adding or subtracting X, I'm going to assume X is tiny if K is tiny. So this becomes just 0.04 and divided by the reactants, 0.08. So this becomes 3.6 times 10 to the minus 5 is X. And what did I ask for? The pH. So pH is negative log of this. Does anybody know what the answer to that is?
4.4.
And look, it is 1 o'clock right there. Class is over. Thank you, girls.